Introduction to Operating Systems and Memory Management. In this video, we will look at the roles of an operating system, how an operating system manages resources, and how it manages the computer's memory. Operating systems manage the computer's resources, such as memory, input-output devices, hard drives, and the like. It provides an interface through which humans can interact with the computer. The various roles of the operating system generally revolve around the idea of sharing nicely. An operating system manages resources, and these resources are often shared in one way or another among programs that want to use them. Most computers have more than one program running on it at a time. Multi-programming is a technique for keeping multiple programs that compete for access to the CPU in main memory at the same time so they can execute. Memory management is the process of keeping track of what programs are in memory and where in memory they reside. Let's define a couple of terms. A process is a program that is currently running, a process in execution. Process management is the act of keeping track of the progress of a process and all the intermediate states. It's keeping track of the registers and all of its variables. CPU scheduling determines which process that's in memory is being executed by the CPU at any given point in time. The operating system must keep track of where a program resides in memory. It converts logical addresses into physical addresses. When we were writing our assembly language programs, we started from address 0 and worked our way forward from there. Those addresses that we used are the logical addresses. The physical address is the actual address that the computer has placed the given program into. The logical address is the value relative to the starting point of the program. The physical address is the logical address added to the starting location in main memory. So let's assume that our memory is here on the left side of the screen. And we're going to say that when we wrote our assembly language program, we used address 23 for our variable $sum. Now, while it's 23 in our assembly language program, it is not going to get loaded at the beginning of memory. It is going to get loaded somewhere in the middle. And the operating system needs to map that address 23 to its physical location. There are three different approaches to memory management: single contiguous memory management, partitioned memory management, and paged memory management. In this video, we'll look at single contiguous memory management and partitioned memory management. In the single contiguous memory management model, there are only two programs residing in memory: the operating system and one application. This is called the single contiguous memory management approach. The operating system always loads beginning at location 0. Let's say in our example that our operating system has only 50 instructions. So it would be running from 0 through 49. Our application program could then start loading at 50. Now, in our application program, we used the relative location 23 for our variable sum. Now, it can't load here. That's the operating system. Our variable sum is going to be somewhere in the middle. It's going to be 23 down from the start of where the application was actually loaded. So The application started loading in our example address 50. 50 and 23 gives us 73. So sum in our example here will be at address 73. At any one time, memory is divided into a set of partitions. As the operating system, some will be empty, and some will have programs that are running at one time. Each partition has a base register and a bounds register programs. Fixed partition. The base register holds the beginning address of the current partition. In fixed partitions, main memory bounds register holds a set number of partitions, which programs can be loaded into. Dynamic partition. Let's look at how the base register and the bounds register work. For a given process, and we're going to look at process 3, we will have a base register, and we will have a bounds register, which we're going to call A and L. A states where the process begins. It cannot have an address smaller than that. L is the end of the process. The process can't exceed that. So at any time, the operating system needs to make sure that the bounds register L is greater than or equal to the base register plus however long the process is. There are 3 ways to select how to place a new process into memory: first fit, best fit, worst fit. In first fit, the process goes into the first partition that is large enough to hold it. In best fit, the operating system looks for the partition that is just big enough to hold it, so the smallest partition that is sufficient to hold the job. Worst fit looks for the largest partition and places the job in that partition. The operating system will handle each request in the order received. It will treat each new request as an independent event. Depending upon the partition selection algorithm in use, it will determine which block the process will be assigned to. This will be dependent upon the request starting location and the request ending location. This is a snapshot of memory in our computer. The gray partitions are ones that are in use. The white partitions are available for us to place our jobs into. The very first partition will always be the operating system. It will start at 0. In our example, the operating system runs from 0 to 19. This partition starts at 20. This partition that's in use starts at 30. This partition starts at 35. The numbers show the start of each of these partitions. The partition here runs from 20 to 30, which means that we've got 10. This starts at 35 and runs through, but does not include 40. So we've got 5 there. We've got 6 here. We've got 23 here. We've got 20 available here. And from 130 to 170, we've got 40 available there. Let's look at each of our 3 memory management approaches. For each of the 3, we're going to have 3 jobs. A, which is asking for 6 megabytes of memory. B, which is asking for 3 megabytes of memory. And C, which is asking for 19 megabytes of memory. In first fit, we're going to look for the first open partition, starting from the left, that will have enough space for each of these 3 jobs. A needs 6 megabytes. Well, that will fit nicely here because 6 is less than the 10 that we have available. So A will run from 20 to 25. We will then note the start of the remainder. So what remains open is from 26 through 30. New request B will fit nicely in what we have left over here. So B will go from 26 through 28, and we'll have 1 megabyte open in here for 29, starting at 29. Job C. Job C is 19 megabytes. It will not fit into the 1. Here we've got 5 open. Here we've got 6 open. This is potential. From 57 through 80, we've got 23 available. So C can go here, and the remainder will be 19 greater. So that will run up to 76. Best fit. Best fit is going to look for the smallest partition that is just enough to fit the job request, starting again from left to right. Just for our own sakes, 20 to 30, we've got 10. 35 to 40, we've got 5. 50 to 56, we've got 6 available. 57 to 80, we've got 23 available. 90 to 110, we've got 20 available. And 130 to 170, we've got 40 available. A is going to fit perfectly right into here. Nothing left over. B. Well, 35 to 40 is the smallest partition that will fit 3. So B will go here. But it doesn't use all of it. So it will run from 35 to 38. Will be the beginning of our next opening. And we've got a request for C at 19. 19 will fit there. So there's our C. And that will run up till 109. Best fit. Worst fit. Worst fit will look for the largest partition available and place the job there. So again, we had 10 available here to start with, 5 there, 6, 23, 20, and 40. So A is going to look for the largest open partition, which is over here. So A is going to go there. It will run from 130 to 135. The new beginning will be 136. B will also fit here. It will go from 136, and the new opening will be 139. 139 to 170 is 41. I'm sorry, 31. That's still bigger than any of the other partitions. So C will go here. And 19 more is going to be 158. So from 158 through 170 is still available. Well, that's the end of our first operating system video. Please fill out the worksheet. The next video will be process management. If you have any questions, please reach out to me. Send me an email. Come to my virtual office hours. Be well.